Hello guys, and welcome to the first session of the online classes. To be honest, this method of teaching is new for me too, so please be patient with me while I learn how to record and write on this notepad here. So I hope that you all had the time to take a look at the warm-up video that I uploaded for you. So that just gives you an idea of what we are going to talk about in chapter 24, and that is alternating circuits or alternating current circuits, what we call AC circuits. I have uploaded the addendum to the syllabus, which shows the changes that is going to be for the rest of the semester. Basically, instead of having 2 sessions per week, we'll have like weekly assignments and weekly lectures. So I try to upload the videos per section. So in that case, the video is just easier for me to upload, and it might be easier even for you to watch, because then you can just like take your time and watch each section at your convenience. Okay, let's continue with section 1 in chapter 24, 24.1, alternating voltages and currents. Now, when you plug a lamp into a wall socket, the voltage and current supplied to the light changes sinusoidally with a steady frequency. So like the video that I uploaded previously for you, the lamp which has the voltage and a current flowing into it completes 60 cycles each second. So this means that the frequency of the current in our lamp is 60 Hertz. Now, because the current periodically reverses its direction, we say that the wall socket provides an alternating current, which we show by AC. Now, I want you to please pause this video and have your book besides you, if you're using the online version of the book, have your book ready for the chapter 24 and take a look at figure 24.1. So when you have the lamp in the system, we indicate the bulb by its equivalent, which is a resistor R. So this resistor here, R, basically means that you have a lamp in the system. Now, what produces the voltage in the alternating form is called the AC generator, and that is what I show here by this symbol. So basically, whenever you have this symbol here, it shows that you have the AC generator or the AC voltage. Now, that the voltage that is delivered by this AC generator can be represented mathematically by this following equation. In this expression that you see here, Vmax is the largest value that the voltage has during its cycle, and then the omega is the angular frequency. So angular frequency here, I can write it to be 2 pi f, and this f is the regular frequency that you have, which is in the US, for example, it is 60 Hertz. Alright, so if in a circuit you only have the generator and a resistor, for example a light bulb or a lamp, then this is the V that is being produced. Now, if I want to find the current, we know that according to Ohm's law, V equals to IR. So if I want to find the current, I only need to divide the V by R. And this gives me this equation, Vmax divided by R sine omega t. So I can write the current to be Imax sine omega t, and again omega here is the angular frequency. Okay, so if a circuit has only a generator and a resistor, V is Vmax sine omega t, and then I is Imax sine omega t. Now I can plot the diagrams for these two and then see how they are compared. Okay, so this is the figure 24.1 here, and shows you the voltage versus T, and you can see that it is like a sinus wave, so it is periodic. Now if I want to plot the current with its relationship to T, then it will look something like this. Okay, so sorry, this is not a really beautiful picture, but you can see that it looks something like this, that V and I are in phase, meaning that they reach their zeros at the same time, they reach their maximum at the same time, and then they reach their minimum at the same time. So when this happens, we say that the voltage and the current are in phase. So the voltage and current in a resistor are in phase. But if we have like another components in the circuit, for example, if we have a capacitor, if we have an inductor, then that is not always the case. We'll see in future sections that the voltage and current are not in phase anymore. So, but let's just focus on the circuit that only has resistor here, so that voltage and current are in phase. Now we use something that makes our life easier when we talk about the voltage and current and their difference or their similarity in their phase. These are called phasors. Phasors. So look at this figure here. This is figure 24.3. This shows a vector of magnitude V max rotating counterclockwise with the angular frequency omega. So this rotating vector is the voltage phasor. Now, if the voltage phasor makes an angle of theta omega t with the x-axis, it follows that its y component is V max sine omega t. So let's look at this. So the y component here, this vector here, is V max sine omega t. Now again, this is only for the case that we have the resistor in the system. So as I told you, then I is in phase with V. So it's just like logical that I draw the vector to be in the same direction. And then if I project it on the y-axis, then that gives me I max sine omega t, this vector here. So I can say that the voltage phasor for a resistor points in the same direction as the current phasor. Now again, we are going to see other cases in which the voltage phasor and the current phasor they don't point in the same direction. They have a lag, so there is a phase difference between them. Oh, okay, so both the voltage and the current in figure 24.2, they have the average values that are 0. Now V average and I average, they give very little information about the actual behavior of V and A. That is why it is more useful for us to find another type of average, which we call the mean, or the root mean square, what we call it RMS for short. Now, I don't want to trouble you with the calculation for that, because that is something that you can take a look at your book. Page 847 gives you the how to derive this equation here. But what is important for us here is to know that I RMS is equal to 1 over square root of 2 of I max. So I can write that the VRMS is 1 over square root of 2 V max. So the root mean square value of every component is just the maximum of that component divided by square root of 2. When it comes to V, it is the same. Alright, so from now on, we are just talking about two types of values, either the maximum or the root mean square value. And I'm sorry, it seems that I have missed one E here. Alright, now take a look at the exercise 24.1. It says that the typical household circuits operate with an RMS voltage of 120 volts. What is the maximum or peak value of the voltage in these circuits? Okay, so this is a straightforward problem. So we have VRMS to be 120 volts and we're looking to find Vmax. So from this equation here, you can write Vmax to be square root of 2 times VRMS. So this is easy, just plug in the numbers and then your answer is 170 volts. Okay, another thing that we want to remember is that, do you remember the Ohm's law, V equals to Ri? So this is good to know that whenever we are talking about max values, both sides should have max values. So Vmax is R times Imax, but if I'm talking about RMS value, then both of them should be RMS. So we cannot use one of them to be max and one of them to be RMS. Both of them should be the same type of the value. Okay, now it's good to talk about what happens to the power. So previously we knew that power can be derived from 2 or 3 types of equations. Okay, take a look at these two equations for the power that we have used previously. So if I want to find the average power, then here I should have see my mistake. Here I should have the RMS value. So P average is R times I squared, but the RMS value of the I squared. Now, same happens for when I'm using the equation V squared divided by R to find the average power. Then this V here should be RMS value. So because this root mean square is same as the average, notice that whenever you want to have the average quantity that is derived by putting the other quantities like current or voltage, then you need to use the RMS value for the current and the voltage. Okay, so let's try to solve example 24.2. It says that an AC generator with a maximum voltage of 24 volts and a frequency of 60 Hertz is connected to a resistor with a resistance of 265 ohms. Okay, so these are the known of my problem. I have written them down, that Vmax is 24 volts, frequency is 60 Hertz, and that the resistance is 265, and I want to find the RMS voltage. Okay, so from previous equation, I know that VRMS equals to Vmax divided by square root of 2. So just plug in 24 volts for the maximum of voltage and divided by square root of 2, and then I get 17 volts for the VRMS. Okay, in part B, we want to find, as the question asks us, the RMS current in the circuit. What is this? So you remember the Ohm's law? So according to this, then I is V divided by R, but because I'm looking for the root mean square, I need to plug in the VRMS here. So I'm going to divide 17 volts that I have from part A by 265 ohms. So this gives me the value of IRMS to be 0.0642 amps. Okay, in part C is asking for the average power. What is the average? To solve this, you can use either of these equations here. You can either use the average power equals to R IRMS squared or the VRMS squared divided by R. So no matter which one I use, I just get the P average. Let's just go ahead and use the second one. So the P average will be 17 volts squared divided by 265 ohms, and this gives 1.09 watts. And remember that the unit for the power is watts. Okay, part D is asking for the maximum power dissipated in the resistor. So I'm going to try to find P max. Now, again, so if I'm using max in the left hand side, then I need to use the max on the right hand side too. So I'm going to write P max equals to V max squared divided by R. So it's just enough that I put the maximum value of the voltage here. So I am plugging in the 24 volts, which was the maximum of voltage, and I missed the unit here, and then squared divided by 265 ohms. So I'm getting 2.18 watts. Okay, so this here brings us to the end of section 1 in chapter 24. There are several conceptual examples in the book that you can study on your own. I just want to again remind you that when we have the circuit that only has the resistor in it, we show it by this symbol here. So this is the AC generator here, and then you have the resistor here. Now in the next section we will talk about the circuits that has capacitors in them. Instead of R, we are going to have capacitor. Please let me know if you have any questions. You can email me and I answer within the 24 hours. Also, I will open a discussion board in which you can just like bring up your ideas or questions, and people can answer you, I can answer you, so that everyone is seeing the questions and the answers. Maybe that help them too.